All right, some more stuff on the command line. I want to talk a little bit about aliases today. Shell aliases are a kind of macro that things like bash and zsh provide that allow you to do it saves you on typing and it saves you from errors and it's useful. So let's say that we create an alias. And then I can use that alias just like I would the command, and it gives me those particular set of options. So if there is some reason why I want to change it or I want a default set of options, then I can use that alias to get it. In fact, if you just run ls, okay, you'll notice that it doesn't do any coloration of anything, whereas normally when I run ls, not only does it come out in a multi-column format, but it uses colors. And that's achieved by having an alias on the ls command on my system that says to use the ls colors coloration scheme. So I use aliases pretty frequently. It saves a lot of typing. It allows me to create macros. This alias right here is extremely common, as in most of the time when you set up a shell, this is just included in the shell setup by default. And the way that aliases work is it is a from name equals a replacement string, and you can have arguments in that replacement string. You'll notice that there are quote marks there because I have spaces inside my set of arguments over here. And if you have characters over here that are not just A through Z, uppercase, and 0 through 9, you probably want to quote this as well. Aliases cannot be found for everything. You can't alias, my favorite dog to his name is Blue. Okay, because it just can't find the string with spaces my favorite dog. But anything that's a non-blank command at the beginning of a command can be aliased. So there are some common examples that I'm going to show you here, like gs is get status, and if we're using get and we use it frequently, we do this a lot of times. I'm not in a get directory here, but we can change to one. Okay, and I get a bunch of status about this. I use this regularly, and consequently I can have an alias. I can create one, and then I can do just gs, and I can get the same result. So it saves on a lot of typing. It can save you from errors. Certainly, my favorite one is I have this because I regularly leave the space out between cd and space ... So I actually have an alias that aliases cd ... to cd space ... because I make that typo. Occasionally you want to get around the alias. You want to say, yeah, but don't alias it, just give me the base command. To do that, all you have to do is put a backslash in front, and once you do that, you can get to the underlying command. You can also find out what an alias is by just typing alias and the name. So alias ls, if I do that, I get that I'm actually running a different ls command called a gls with color auto. And color auto is the thing that gives me the pretty colors for my file names. So yeah, you get to change with some macro capability what the commands are with aliases. Now, one of the first questions you get with stuff like this is, how do I set this up automatically, or do I have to enter these every single time? That would be pretty useless. And the answer on how you set it up automatically is dot files. And these generally start out with a period. That's why they're called dot files. And they live in your home directory. And this is true for Unix systems. On Windows systems, we have something entirely different. But if you use the bash shell, like you install git, and you're using bash on a Windows system, again, the dot files would live in your home directory. And they start out with a dot. Usually they end with RC, like there's a .vimrc, or a .bashrc, or a .zshrc. There's a couple pieces of history here. First of all, the dot. In the history of Unix, they wanted to create directories, and when they did, it was all written in assembly language, and they checked for the first letter in the file name being a dot. And this was good when they just had a few directories, and then they wanted to create a directory tree, and they had all of these files, and they wanted to stick directories in directories to create a hierarchy, but they needed a way to refer to the parent directory. And the software was already set up to just check the first character and ignore it if it was a dot, so they created ... as the parent directory. And this was all good, and it was nice and easy to check just a single character inside the program. So this lived on, and eventually they built other things, and they wanted to have files that by default didn't list, and the ls program already had a check for the very first character being a dot, so they named it dot, and you had dot files. So that is kind of the history of the dot. Now, what's the RC at the end? In the history of Unix, it was a joint project between IBM and AT&T Bell Labs to build this Minix operating system and later Multics operating system. And these operating systems that they built, Multics was what they were working on, had some nice features to it. It was a research operating system, but it had some nice features, and then IBM canceled the project. So the guys at Bell Labs were bummed out, and they had this Space Invaders game that they really wanted to play, but they didn't have an operating system, and they looked at how difficult it would be to port Space Invaders to some other system that they had, and decided it was way easier to implement an operating system. And instead of this multi-operating system that they've been working on, Multics, they decided to create a unified system called Unix. So they implemented Unix to run their Space Invaders game. Now, one of the features that Multics had was all of these run commands, and you had to end the run commands with an RC. So when they built these scripts that got run at the beginning of stuff, they wanted it to be a run command, so they called it things like vimrc. And that's where you get the RC at the end, because it's a run command from an operating system that got built in the mid-1960s. So we're stuck with RC. Now, with vimrc, you can put commands in there that the editor will run at startup. For instance, we talked about the fact that if you want to have line numbers in Vim, you can do :set nu. Now, if you go create a vimrc and you put that :set nu in it, then every time it runs, it will give you line numbers. And let me... You'll see that I have a vimrc that just has that in it. Let's just remove it and see what the effect is. I'll edit a file. You'll notice there's no line numbers. I just put in a couple blank lines. Let's make those B, C, so I've got 3 lines. You'll notice there's no final numbers. Now if I do vi.vimrc, and now I go back to edit my other file, you'll notice I get 3 line numbers. That's the 1, 2, 3 over there. So you can set commands that you want to configure the way your editor works inside this vimrc. And whatever default set of commands you have that you want run all the time, you can put in there. If we look at my vimrc that I work with, you'll see that I have all sorts of commands in here. And some of these actually configure the editor itself with various things like a color scheme, this spelling checker. VI has the world's best spelling checker, and you know that I need it because I keep making spelling errors in handouts. So you know I really, truly need a good spelling checker. And I use it all the time, and hopefully it corrects most of these, but I still make mistakes. So I have hundreds of lines of configuration and comments and stuff like syntax highlighting and coloring for different languages set up in my vimrc. Uh, what about some of these others? That's the editor. Okay. The thing that you're probably going to want to configure the most often with one of these dot commands is not the editor, it is your shell. And originally the shell that was written for Unix was sh, and then there was this Korn shell, ksh, developed by a guy at AT&T Bell Labs called Michael Korn. And then we have the Born Again shell, which is not a religious reference. That is from a guy named Born. Okay. And that's called bash. And bash was a clone of ksh, which was a offshoot of sh. So the reason you need to know this is because bash tends to run the following dot files: .bashrc, .profile, and .bash profile. And the reason it does this has to do with the history of the shell. .profile was run by sh and ksh. And bash, because it was different, had to have some different configurations. And so some systems will run .profile and then .bashrc, or .profile and then .bash profile. If you're using ZSH, it runs .zshrc. But basically, it's kind of like the vimrc. You get to put commands in there. Like if you want to have aliases set up all the time, you can stick it inside your file. And you can put it in that file. Which one gets run is a little bit of a mystery to me on all systems. It depends on some other system configuration and whether or not you're mimicking a BSD OS or a System 5 Unix OS. So I usually stick stuff in, and if it doesn't work right away, I immediately put in some echo commands, and I go find out which one is getting run, and then I put my stuff in the correct one. Now, another thing that you can put in these is you can put in variables. And I use variables all the time in the shell because I think the shell is a programming language, and I'm just interactively sitting here programming whenever I run stuff. So some stuff that I like to have is my paths to long, deep, hard to get to things. Like I might do in my shell export. I'll get back to what export is, but I create a thing for UW that says the path to my files for this class and other classes is this big long thing. That way, when I do a cd command, I can do cd to $UW, which is reference the variable and pull it up, *50 lectures *32. And I end up in this big long path, but I didn't have to type most of it. And I use some wildcard expansion in the middle and a variable. And the shell is perfectly happy to substitute the variable and then fill in the rest with the wildcards. So that saves me lots of typing, and I get around big long paths without like burning the tips of my fingers off. I guess that's the key there. Okay, now export. Whenever I create variables, the question for variables and things like the path, which is a special variable, but it's still a variable, is who can see it. If you set variables in the shell, but you don't export them, then those variables are only good for the shell that you're in. Now, when you run a program, remember the way Unix does it, is it takes the program and it does this thing called fork. So the parent shell becomes two shells. The parent continues to be a shell and does things like wait. The child inherits all of the exported variables. And those exported variables in the child now become part of the environment that the child replaces itself with something like ls it wants to run, but it still gets all the exported variables. So any variable that I export becomes visible to child processes that I run. Now, I can run a child process like, if I do ps, you'll see that I am running ZSH. But I might want to temporarily run a different shell, like I might want to say bash. And now I am in a child process that is a different shell running inside a shell. And if I do env, you'll see that I still have all of my paths set up from these environment variables that I have exported. If I didn't export them, they wouldn't come through to a child process. One of the most important uses that I have seen for exported environment variables is you have some program that you'd like to put on GitHub, but it needs to have usernames and passwords in it. And you'd really prefer that your usernames and passwords to things like your Amazon account is not shipped off to a public repository at GitHub. So instead of putting those into the file with your code, what you do is you pull out the environment variable and you use this environment variable, whatever it is, Amazon username, Amazon password, that kind of stuff. But you don't actually put those into your code. You store those in environment variables that you store locally on your system. And you set them up in something like your dot file. That way when you run your program, it works, but you're not shipping the code off and telling the world, here's my username and password, why don't you hack into my account and spend $30,000 of my money? So that's usually a good thing to do.